What is up, guys? DevCode here. So I've made a few changes since the last episode, and I know it's been a little while since I've done a video on the parser, but I've basically been trying to figure out how to do some improvements and updates on the language itself. So I've added a few more files here, and you can ignore them for now because as the tutorials goes on, we'll eventually get to all these files and then keep progressing forward. Okay, so where we left off was we left off kind of in this area where we had the runtime and we were getting ready to start writing the parser. So the first thing to note is that back when I mentioned in the previous episode for method declaration and operator declaration, I had fn here to kind of start a function. So for our syntax before, it was kind of going to look something like this. We would have fn and then main. Fn was short for function, but now it's just going to be def, which basically means define a function and everything else is pretty much the same. This is just a new format. Also, something else to note, in our statements, we had something called a macros declaration statement, and that's no longer there either. It doesn't really make sense to have a macro function in this language because it doesn't really serve any more purpose other than you can't return anything from it. I also made a few other changes in the project as well regarding how it's compiled. So if you remember in our previous episode, I wrote out how we were going to create our CMake file and compile our code. Well, I've switched our compiler from the standard C++ G++ compiler to using GCC compiler. So if you guys don't have GCC, you can download it online. Just type in mingw. But basically, all you need to note is that here I am specifically specifying which compiler I'm using on my machine specifically, which is the mingw GCC compiler. Also, I made a few changes to the flags down here, so you can see that I have CMake flags release. Before, I believe I had CMake flags mini release. So basically what I did was I added a new type of build configuration, which is called release, which doesn't favor size, it favors optimization over size. And the size of your executable really doesn't matter in this case because it's not going to be that big anyway. Also, when using the GCC compiler, you have to specify this option -lstd C++, which basically tells the compiler to import all of the C++ libraries that we're going to be using in our code into the project. Otherwise, if we didn't put this option in, we would get a bunch of compiler errors saying it doesn't know where these objects are referencing from. Alright, so the first thing we actually have to do is we have to start writing the error management system. So we're going to go over to errormanager.h, and the reason why we have to start with this first is because the parser is going to need to have this class available once we start building it. So if we try to build the parser or try to build the tokenizer first before we build the error management system, it's not going to work. So I've already added the appropriate imports here that we're going to need for this to work. So we're going to need something that's called list.h, which I will get to. We're also going to need our token entity class, our key pair class, and our standard imports that's used throughout the project. And then we're going to need our C++ list class. Alright, so the first thing we need to do is we need to create an enum called error type. So once we've done that, we need to create a series of errors that are going to be the most common errors that we're going to expect in our compiler as a whole. Alright, so I've already created all of the different types of errors and they are listed in no particular order. So basically the rundown of all of these errors are we're expecting to run into an error such as an unexpected symbol, unexpected end of file, a generic error. Basically what generic means is we are not going to print out an error. Basically what we're going to have to do is we're going to have to write in a custom error based on that specific circumstance. We'll also expect errors like duplicate class, so like if you have a duplicate class or duplicate variable or something like that, we'll have errors like that and so on and so forth. And no error, most likely we won't run into this, but this basically just means we don't know what kind of error it is. Probably won't get used, but it is a good practice to keep it there just in case. Alright, next we need to create a static list of a key pair, and then we're going to label this predefined errors. Alright, so basically what a key pair is you can think of it as a class that holds a key and a value. So the first thing we need to do is we need to create a list called predefined errors. And basically what this is going to do is this is going to hold all of our predefined errors that we're going to be giving to the user whenever we catch any one of these errors. These errors up here, as I said before, are errors that will most likely happen during the entire time of our compiler. If one of these errors aren't listed, then we'll just use the generic error and then create our own specific error for that case. So the first thing we need to do is we need to create a key pair. So we're going to go in here and create a structure called key pair. And in this structure, we're going to need to have a template. Then we're going to need to create a key pair constructor where we're going to say k key and t value. Next, we're going to create just an empty construct, just so that way we can initialize key pair without having to have these arguments. Next, we're going to need a function called set. And basically what that's going to do is that's going to allow us to set our keys and our values. Finally, we're just going to hold our key and our value, so our variables that we've been using before, we're just going to hold those. Alright, so now we've done that, we can go back to our error management class and our key pairs should be fine. Next, we're going to create a function called initialize errors. And basically what this function is going to do is this is going to set up our predefined errors. So before we do anything in our compiler, we're going to need to store the text for all these predefined errors, so once we run into them, we can just pull them straight from this list and use them. So the first thing we need to do is we need to create a class called ParseError. And this class is basically only going to have one purpose, and that purpose is going to be to hold the error that we're complaining about. So if in our compiler, as we're recording our errors, we're not going to always just print them directly to the console, because as we're parsing our code, we can't complain about every error that we encounter because there's no guarantee that that's an actual error. So we need to store our errors somehow and then use them later to be printed to the console. All right, so the first thing we need to do, of course, is we need to create our empty constructor class. And in there, we just need to initialize some variables. So before we initialize our variables, we need to actually create them. Our variables are going to basically consist of error type, which is going to be the ID or the type of error that we're complaining about. Error, or basically the error message that we're going to print to the user. This is going to be the real error message that the user is going to see. Line, so what line did the error appear on? Colon, so we need this because we can have multiple errors on a single line, so we need to know specifically where each error is. And finally, warning. So this is basically a Boolean that tells whether or not this error is a warning or it's an actual error. Alright, so now that we have our variables, we can start initializing them in our constructor. Alright, so the next thing we need to do is we need to create another constructor for our ParseError. So this constructor is basically going to require us to pass in a ParseError, and we're going to just call the operator equals to ParseError. The reason why I'm calling specifically operator equals is because we're actually going to create our own operator overload below in this class, so it'll end up calling that operator overload instead of just assigning it. And the reason why we want to do this is because we don't want any weird things to happen with our string class, because there are some instances where if you're copying strings in C++ and you're not destroying the objects and copying them correctly, you could get some seg faults and stuff like that. Alright, so there's a couple of different constructors that we need to create, so I'm just going to kind of zip through them so we can get on to writing the actual code. So the first constructor that we need is going to require a key pair, error type, and a string. And basically what this is this is the actual error that we're going to be passing to our ParseError. So this error is going to have the error type, which is basically going to say, is this a generic error? Is this a illegal access declaration error? So what type of error it is. And then we're going to have our string, which is the actual message that we're going to be complaining about. Of course, we're going to need our line and our column, and then we're going to need an add-on. Basically, the reason why we need this is we have up here a set of predefined errors, and each of these predefined errors are going to have a set of canned text that's going to already be printed to the console that's going to explain the error. But if we wanted to explain a little bit more, instead of just printing out an error saying you have a duplicate class, we also would want to know what class is being duplicated. So we would use this add-on string right here to just add on to the already canned error message, so that way we can have a little bit more information. Next is pretty much the same thing, except we have a Boolean flag with warning. Alright, so in this constructor, it's a little bit different because instead of us passing in a line and a column to tell us specifically where the error happened in our code, we're passing in a token entity. Now, if I do Control B on this, we haven't actually created what a token entity is, but basically what a token entity is it's a class that holds information about a specific token. So basically all we need from here is we need to get our line and our column. We don't care about anything else in the token entity class. And you can see here that we're already having errors. We're going to fix that once we start working on the token entity class. All right, so the last thing we need is we need our operator equals function. And you saw up here I called the operator equals, which is now, instead of going to just assign this class to ParseError, but it's actually going to call this function, which does some special stuff. So this is really only the main reason why we need it. We just want to make sure that we're correctly copying and using our string classes appropriately, so that way we don't get any weird seg faults with char array errors and other stuff later. And then of course we take all of our other variables and just assign it as you would expect in an equals function. Alright, so next thing we need to do is we need to create a class called AST. And we're not creating a class, we're just predefining this class because we can't include the class AST in this header file, because if we do, then we're going to create a recursive loop of includes. Alright, so the next class we need to create is going to be our error manager class. So basically what this class is going to be is this is going to be the official class that's going to manage our errors. So this is going to be the full error management system that's going to hold every single error that our compiler runs into. And it's also going to destroy certain errors, so it's going to ignore certain errors if they don't need to be printed or if they don't need to be reported, and so on and so forth. So in our error management system, we're going to need a couple different things to process our constructor correctly. The first thing we're going to need is we're going to need to know all the lines that we're going to be processing in our code. The next thing we're going to need is we're going to need to know the file name of the actual code that we're processing. Then we're going to need to add a Boolean called as is. Basically what this Boolean flag is going to be responsible for is we're going to need to tell the error management system, do we want to print the errors as is? Or in other words, as we're storing the errors in our error management system, we're just going to directly print them to the console, and we're not going to even worry about storing them. So there are a couple of cases in our compiler when we're going to want to do this, and that's why I added this flag. And finally, we're going to need to tell our compiler whether or not we want to enable aggressive error reporting. And basically what that's going to do is our error management system is going to be smart enough to know which errors should be reported and which errors shouldn't be reported. So let's say our error management system found 2 errors at this line and column right here. So the line is line 113 and the column is 61. Now, if we ended up getting 2 errors for the same exact line and column, the compiler is going to know to only pick one of those and throw the other one out. But if we enable aggressive error reporting, what that's going to do is the compiler is going to complain about every single possible error that it would have ever found in our compiler. And this is helpful because there may be some scenarios where our error management system isn't reporting errors efficiently enough. Alright, so now I've added a little bit more code here, and as you can see, these are all the internal variables that our error management system is going to have. We're going to create those next. So basically, all we're doing is we're just setting up our variables based on our parameters that we passed here. So we're going to need to add all the different lines that we're going to be processing in our file. We're going to need to know the file name, and we're going to set a few array lists here that are going to hold some different information. So the first thing we need to do is we need to set all these variables to private, because we really don't want anybody outside of this class to be accessing and fiddling with these variables, because it'll mess things up. So the first variable we're going to need is we're going to need a variable called lines. Next, we're going to need a list that's going to hold our parse errors. So we're going to need to hold a couple of different things. So we're going to need to hold our errors, which is going to be all the errors that our compiler encountered that were filtered. Unfiltered errors are basically going to be every single possible error that our compiler has found since inception of this class. And the warnings are just what it is. It's just going to store any warnings that we're going to have in our compiler. And if you didn't notice before, we're passing in the file name for our error management system, which basically means that we're going to have one single error management system per file. So we can't use the same error management system for every single file in our compiler. For every file that we compile and process, we're going to need to create a new error management system. The reason why I split up these two errors is because we have this aggressive error reporting flag here. And what that's going to do is when we are reporting our errors, there are going to be lots of errors that are going to be filtered out that we're not going to have. So if we disable aggressive error reporting, let's say our compiler found a total of 100 errors, our compiler may only end up reporting about 27 of those, because those are the only errors that are relevant based on the logic that we put in our error management system. So this errors list will only hold 27 errors, while our unfiltered error list will hold our full 100 errors. Next, we're going to need to hold a list of possible errors. Basically, the reason why we need this list is because as we're running through our parser, we're going to be parsing every single token in our file. And there may be some cases where we're trying to parse an expression, and what we're parsing may end up not being an expression. So as we're building up errors while we're parsing, we're going to be stashing those errors in our possible errors list, or you can kind of think of it as a cache. And once we've realized that what we were looking for is what we're looking for, but the user did it wrong, we'll then take all those errors out of here and dump them in the appropriate list. Next, we're going to need TE cursor. Basically what this is going to be is this is going to hold the cursor to where we are in this possible errors list, because when we're running our parser, we're going to be bouncing around in this list a ton due to recursion. So we just want to keep track of where we are in this list, so that way we can print out and feed the error management system the appropriate errors that need to be complained about. Now this is where we get into making our error management system somewhat smart. So we're going to need to have a variable called last error. And basically what that's going to do is this is going to record the last error that we just complained about. And we need this because if we complain about error A and then we complain about error A again right afterwards, it doesn't make sense to really report that because we just complained about it. So that's why we have this last error here, so that way we can do our comparison. Next, we need to have last checked error, more on that later. And then finally, we have a few boilerplate variables left over. So we have this Boolean, which basically means, has there been any errors at all in our error management system, or has our error management system found anything? We're going to have as is, which I already explained that above, and aggressive, which I've also explained. And then we're going to need to have our file name for our file that we're processing. All right, so now it's time to start creating our functions for our error management system, and there's going to be a bunch of functions that we're going to need to make this entire system work. So the first function we're going to need is going to be pretty obvious. It's going to be called print errors, and that's going to just print all the errors that we found straight to the console. Next is going to be get error count, and what that's going to do is that's going to get the full amount of errors that we have in our error management system. But remember, this error count size might be different than our unfiltered error count size because this is our groomed errors in our compiler. Next, we need to know how many warnings that our compiler has also found, so we'll have our get warning count function. Next is get unfiltered error count. So this will tell us how many errors in total that our compiler has found over the course of its inception. Next, we're going to need a function to create errors, so we're going to have create new error. And we're going to require an error type, so what type of error it is up here. So we'll use something from this list. And then we need a token entity. So if we found an error with a specific token while we're processing our compiler, we will just pass it in through here and extract the line and column that that token is processed at. And then we have our XCMTS, and that's basically short for extra comments. And again, that goes back to being able to add on some extra text to our error if we need to. Next, we need to add another function to create a new error, and same story this time, but except instead of using a token entity to report our error, maybe we found an error with a certain abstract syntax tree. So as we're parsing our abstract syntax tree in our parser class, and we're kind of jumping through them, we may find a potential error with that specific branch. So we would want to report about that error there as well. And then again, we use extra comments if we need to provide any additional information. Next, we need another function for creating new errors. So in this case, if we don't have any of these objects available and we just want to strictly pass in an error and physically give it the line and column, we can do that as well. Next, we need to create a new warning. So this would be any warnings that we find in our file, and we just directly would have to pass in our line and column here. Next, we have another create new warning function. And in this case, instead of passing in our line and column directly, we may have a warning that is in reference to a specific abstract syntax tree or a branch. So we just want to pass that in and use it as well. And we don't have to create all these separate functions with all these different parameters and requirements in here. We can literally just have one create new warning and one create new error and just pass in the line and column. But our compiler is going to be so big that it's just going to be much faster and much cleaner of code if we can just pass in the object directly. Next, we have has errors. So this boolean is just going to return whether or not our compiler found errors at all. So if some of you are thinking with this function that, well, what if we have a situation where the compiler ended up grooming our errors so much that we ended up having 0 errors and 10 unfiltered errors, because maybe those errors happen on the same line and our error management system filtered all those errors out. Well, what this has errors function is going to do is, instead of looking at the amount of groomed errors, it's going to bypass that and just look at the total amount of errors in full. Next, we're going to need to know whether or not our compiler has any warnings. Next, we're going to need to have a function called enable error check mode. More on that later. After that, we're going to need to have a pass and fail function. Again, more on that later. And then we're going to need to have 2 more functions that are public, which are going to be free and getLine. All right, so now that we've created all of our public functions, now we're going to need to create a couple of different private functions that are going to run internally within our error management system to pretty much tie all of this stuff together. So the first couple of different functions we're going to need are going to be getErrorById. So we're going to pass in an error type, and what that's going to do is that's going to go up here to our predefined error list and just kind of extract that error out. Next, we're going to need a getPossibleErrorList, which just returns our possible errors. Next, we're going to add a possible error list and remove a possible error list. That's basically just going to manipulate this list within inside of the list. Now we're going to add the final couple of functions that are going to be pretty much the backbone of the logic for our error management system. So these next few functions are going to consist of shouldReport, and this is going to be a function that's going to basically check whether or not we should complain about this error based on a couple of different criteria that we're going to provide. So we're going to need to pass in our token entity, our ParseError, so we're going to need to know what our last error was, and then we're going to need to know what our current error that we're trying to complain was. And then we'll compare all of that information. Next, we're going to need to have a function called getErrors. What that's going to basically do is that's going to take our list of parse errors, and it's going to string all those together into one giant string, and then return it as one giant list of errors. Next, we're going to need to have printError, which is basically going to directly print a specific parse error that we encountered. Next is hasError, so we're going to check to see if an error list contains any one type of parse error here. And then we're also going to have a function called shouldReportWarning, which is basically going to check whether or not we already warned about something, because just as much as we don't want to complain about certain things, we also don't want to warn the user about certain things multiple times. All right, so now that we've gotten all that out the way, now it's time to actually code the error management system. So the first thing we're going to need to do is we're going to need to create our initializeErrors class, and we're going to need to start creating our predefined canned errors that we're going to be processing in our compiler. So we're going to need to create a key pair with an error type string error, and this is going to be our official error that we're going to encounter. So now we're ready to start writing out all of these different types of errors. So we're just going to go in chronological order of our actual list. So first we're going to need to complain about an unexpected symbol, and we're going to need to take our predefined errors and we're going to push that back. So I'm just going to quickly go through these so that way we can get to the next step. Next is going to be illegal number format. And this is if you have a number such as a hex value that's malformed or of some sort, then we will complain about it here. Next, we're going to need to have an unexpected end of file. That's what EOF is short for. And that's if we run into, let's say we need to process this bracket and it wasn't there, then we would reach the end of the file before we expected to process that bracket. The next error is going to be string literal EOF. So let's say we were processing this string here and we ran into an end of file. It's actually going to complain right here. So we can actually look at an error message from CLion right here that says unterminated string literal, and this is basically the same thing. Next, we're going to need to complain about an illegal string format. Next is expected char literal EOF. So if we were going to have, let's say, a character with the letter T in it, but we ran into the end of the file before we processed it, then we want to complain about that as well. Next, illegal character literal format. Next is generic. And the reason why this is blank is because a generic error has no message. So in this case, we would actually use the extra comments or the add-on here to literally pass in our specific error message. So we can say whatever we want, and that's how our custom error will be built. Next is going to be an illegal access declaration. Basically what this is if we specified an access specifier, like in C++, you can't specify that you're having a public variable inside of a function. You can't even do that in Java either. And that doesn't really make sense to have a public variable inside of a function, so that's what this is for. Next, we're going to need to complain about an illegal bracket mismatch. Next would be a missing bracket error. Next, an invalid access specifier. Next, we have previously defined. This also has blank text because we want to specifically say what has been previously defined. Next, we're going to need to have a duplicate class error. And you can see here I added this little colon because immediately right after that, I'm expecting to be passing something here. So I would be expecting something like duplicate class main, and then maybe afterwards I would give a little bit more information about why it's duplicated. Next is redundant token, which means let's say you had like 16 semicolons after a statement. It doesn't make sense for you to have that, so that's what that's for. And this actually isn't an error, so this is actually a warning. So if I were to find something like a redundant token, I wouldn't complain this as an error, but it still needs to be in the list because this is a quote-unquote error that we're going to run into often. Next, we're going to have an internal runtime error. I don't remember what this is for, but we'll figure it out later. Next, we have could not resolve. So if we couldn't resolve a variable, of course. Next, we have expected reference of type. I know that some of these errors are a little bit self-explanatory, but I just want to go through all of them so that way you guys don't have any questions later about maybe something that I overlooked, because I know I am going a bit fast because there's a ton of work that has to be done in this compiler, and I don't want to take too long completing all of it. Next is invalid cast of type. Next, we have redundant cast of type. Next is redundant self-import of a module. So let's say we wanted to include a module into our file, and then we included the same module right directly under it. Doesn't make sense to do that, so that's why we need that one. Next is unexpected token. Next, we have invalid access of. Next would be already defined. Next, we have invalid param of type. This will be used probably when we start getting into creating functions in our compiler, and we have some unexpected or invalid parameter. Next, we have incompatible types. And finally, we have duplicate declaration of. Okay, so that's pretty much all the errors that we need to initialize. Any other errors that we're going to encounter in our compiler are going to be sent to this generic function or this generic error, and we'll just print out what the problem is there. That would also work for if we had warnings as well. So let's say we had a warning that is not predefined here, because even though these are in an error list, we could also kind of use these as a warning, but it doesn't really make sense based on the text that's put here, like illegal character, literal format. That wouldn't be a warning, that would actually be an error. But if we wanted to use any of these errors here as a warning, we could be able to do that. All right, so the first function we're going to need to do is we're going to need to write out our print error function. So we already know what this function is going to be used for. I'm just going to again zip through all these different functions because once we get to the parser, it's going to easily be over 1,000 lines of code and it's going to be very complex. All right, so we're actually going to stop here because there's a lot more to be done. And after we finish writing our error management system, we're going to just jump straight into the tokenizer. So hopefully you guys enjoyed the video. Definitely like and subscribe if you want to see more. So until next time, see you guys later.